we'll learn few advanced things. Okay, starting from the how we can create a function, how to combine the functionality of a function along with the loop. Then we learn some advanced, even more advanced things like how to generate random numbers. Because we'll be mostly using that concept in the Monte Carlo simulation for portfolio optimization. All right, so let me just start sharing the screen. Give me a moment. Can you guys see the screen?
Yes, sir.
Yes, sir.
All right. So in the last session, where we left was is this, wherein we just extracted the stock price of for the given tickers, and just to add on, these tickers are not just for the equity, but you can see other asset classes as well. You can see there's gold, there's bond, okay, and then you have this index S&P, which is Standard and Poor. QQQ is nothing, but it's an ETF of Invesco, okay, and Apple is a single stock, right? So what we did till here is we fetch the close prices. So as I mentioned that you will get other details also, but what we were actually concerned with was just the close price. So you can see we have close price, high price, open price, right? But we wanted just the close price. So we did this. Okay, so why this error came? Because we haven't run this entire code. So what you need to do, just go to run and just run all the cells. Okay, so run all cells. So it will quickly run it. Right now we have the close prices data stored in this. So I'm just gonna see the output. You see, we have the data here, right? It's a what is the frequency of this? It's a monthly data. So you can see I've set the interval as 1 month. You can change this to weekly also, daily also, 3 month also, right? That you can do it. So we'll just collapse this. Now, there is a function called head function and tail function. What it does is that if we just want to see the top five, just yeah, if we just want to see the top five rows of this data instead of going through the entire data, how I can do that? So for that, we'll use a function called head function. Okay, one minute, there's some issue. One minute, there's some technical issue. Let me just resolve it. Okay. Yeah. So what I was saying that let's say if just I have to, instead of seeing the entire data, if I just have to know the what's there in the first 5 rows or first 10 rows, then there's a function, right? So what we'll do is we'll take this close price and we'll use a function called head function. So dot head, right? And you don't have to specify anything here, right? So if you do just do this and execute it, you see we are getting top 5 rows of this data frame. But here we are not specifying any. So by default, it is giving us top 5 rows. But if we make it 10, then it will give us the top 10 rows of our data. Similarly, we have a function of, let's say, if you want to see what are the last 10 data points, okay, 10 data in the last 10 rows. So what I can do is close price dot tail, right? So by default, it will give you the 5 data points, but you can change it to 10 also, right? So this is what this function does. So head and tail function. Okay, why I'm telling you these small functions? So because these are the frequently asked questions in the interview. Okay. Now, next step is, so we have the stock prices, right? We have the prices, market price here. Now, what I want to compute the returns. How do you compute a return? So computing the return involves 2 data points. We need the uh, date, let's say this date, okay, which is 1st of June, and we need 1st of May. So since these are monthly data points, we need a monthly return. How you'll compute this? So we'll see how much it changed from 200 to 204. So how you'll compute the percentage change? It will be 204 divided by 200 minus 1, right? This is how you compute the change, right? Now let's do this. So basically for this, for performing these type of function, right? And also one thing, we'll be, instead of computing just the normal return, we'll be computing the log normal return, right? So why do we use the concept of log normal return is because we know that these prices cannot become zero, right? So the prices cannot go zero. The equity price or the bond price or gold price, they cannot become zero, right? So the concept of using log return is because these distribution, I mean, if you look at the graph of any asset class like bond or equity or gold or whatever, you'll see that the prices cannot go beyond zero, right? That is why they follow a distribution called log normal distribution, right? So it makes more sense to use a log type of return. Now, in order to use the log function, right, what we need to do for using the log function, we have to import a library which contains that log function, right? So for that, we need NumPy library. So so in case if you don't have installed on your system, so what you can do is pip install NumPy, right? So if you do this, you see, if in my case, it is already installed, right? But if it is not, then if it is installed, then what you need to do, you just need to simply import this library. So import NumPy as NP, right? Now I have imported this library. The next step is to compute the return. So we'll take a variable called log returns. Okay. So again, this will also be a data frame wherein all this data, I mean, all the return data will be stored. All right. So we need to use a log. We need to compute the log return. So how you'll do that? First of all, we need to call the log function. So how you'll do that within the NumPy library? So I'll use np dot log. Okay, there's a log function. How do you compute the return? So log return, how do you compute? So let's say consider this as log m. Consider this as m and consider this as n. So in order to compute the return, you will use the function called, I mean, use the formula called log m upon n. So m divided by n. So for that, how we'll do? So the concept is you'll take this close prices. Now we want to perform compute this log return for all the data points, right? So we'll use this close price. So close underscore price, right? And we'll divide it. So see, this close price reflects what? It reflects all the data frame. Now we want the close price and we want the previous day's close price, right? So how do we get that? So we want this close price again. And in order to get the previous day's close price, we use a function called shift function. So we'll close price dot shift, right? And by how many dates we have to shift? Just one, right? So I'll be shifting by one. Just close this. And once again, close this and execute this. Now the log returns are computed. Now let us see the output, what we are getting. So you can see these are all the log returns you're seeing. For the first row, you are seeing in NA because you don't have any previous date for this particular date, right? So actually the log returns are getting computed from 1st of April 2021, right? So how the 0.073 is computed? It is nothing but log 204 divided by 200, right? So what this shift function does is it just gets you the previous row's data. Got it? Any doubt? Now, since we have this log returns ready, there's another very common thing asked. Now we need to also make sure that this data is very, very consistent. So we don't want this NA in my data frame, right? Because this can create some fuss when we are dealing with this data. So what we need to do, we need to drop all this NA. So for that, we use a function called, since you see this here, we have already computed the log returns, right? Understand? So in this part, we have already computed all the log returns, which is a data frame. Now in this data frame, I want to drop all this NA. So how I'll do that? I'll just use the function dot drop NA, right? And execute this. Just right? So you see when I used, so first of all, a data frame was created, right? With the log returns. Now, when I use this function dot drop NA, it instantly removed all the NAs from the function, NAs from the data frame. Now you see, if I'm again printing it, I'm not seeing NA. So entire row which was containing NA was removed from this, right? So this is how you clean the data. Again, this is also very commonly asked question that how do you remove the NA from the data frame? Understood? Okay. So the next step is this was the log return. Now, what if someone wants to just see the percentage return, okay, which is new divided by old minus one, right? So let's say today the price is 104. Yesterday it was 100. So what is the percentage change? How you'll compute it? You'll do 104 divided by 100 minus 1 or 4 divided by 100, right? So change upon original is how you compute the percentage return. So for that also we do have a function, right? So we'll just call we are going to compute that percentage return. So I'll call this variable PCT return, right? So we have a dedicated function for the same. What's that function is? So we'll take this close price only. See things are so easy when you're dealing with this Python. So close price, okay. What we need to do, we need to compute the PCT change. So PCT dot PCT and underscore change, right? So this is the function. Don't have to do anything and just execute this. Now let us see how this data frame looks like for the percentage change. You see how this data frame looks? But again, same issue. We have a NA. So what we'll do, we'll just use drop NA, bracket close. Now you see you have a proper data with no NA. You see numbers will be almost similar. It will be 0.07, so almost 7% change, right? A 7.3% change here, okay, for the log return. But for the normal type of return, we are getting 7.6% change. So there will be slight difference in the values computed, okay? Understood? Any doubt?
No.
Okay. All right. So here we have computed the percentage return. The next step is, let us just try to, okay, what if, let's say you want all these thing in the form of an Excel, right? How I can get this in the form of an Excel, right? So we'll use a function called dot to Excel. Okay. So this is the data from, I want this in the form of an Excel. One second, 1 minute. Right? So we'll use a function called dot to underscore Excel. Now this is also important, okay? Because you cannot deal with everything on the Python. So let's say I just want it in the form of an Excel, right? So I'll call this, I'll name this Excel sheet as output, okay? Output, and just put an Excel format extension, which is XLSX, XLSX, right? And then use this index.
Excuse me, sir.
Yeah,
Sir, I have a query like you have put to underscore Excel, so it's a function.
yes, it's a function which converts this data frame into an Excel file,
Okay, sir. Okay.
okay?
Okay,
And
sir.
index equal to false, right? Why I'm using this index equal to false? Because it prevents index columns from being overwritten. Okay, I'll show you what how you'll get that. Right now, let me just execute this. F should be capital. Right now, the output will be saved. Now, let me show you the output. So wherever we are storing the original files, there only this Excel will be stored. So let me just show. Right, so I need to go to this. So let's just go to users folder. Okay, then you see we have this output.xlsx. Okay, we'll open this. So here only the file will be stored. I'll open this for you. Just a minute. Let the Excel open. You see, we have all the data here, right? So these are the tickers. This is for Apple, Bond, Gold, QQQ, and SPY. So this is how you can convert any data, any data frame into Excel file. I hope this is clear, right? You can play around with this also. Same you could have done with the prices, right? Now you see, one thing that is missing here is is the date, right? You cannot see the date here, right? So let's just adjust that as well. So let me just go back. 1 minute. Right. So what if I want the date as well? Right. See, so understand what happens is, so this is your data frame. This very first column is actually referred to as the index, right? is referred to as index. So when you are doing this index equal to false, it will not take this index into consideration. Now for in order to get the index, let's just make this true. Okay, and execute it again. Now let us just check the data. So you see, we have the same file because it got overridden actually. Now let us open this file. Oh, sorry, I'm not sharing the screen. Right. So this is the updated file. So it got overridden. So let's just open this file again. Now you see we have the data as well. I mean date as well. Understood? Zooming for you. Yeah. Can you see it? You want you can just play around with this data as well. Is this part clear to you? Okay. I hope this helps. So this is how you can convert your data frame into a Excel, and you can play around with the index as well, how you can add the index. If you want the index, you can add in this way, just put index equal to true. If does not, just put index equal to false. Okay. Now all these things are ready. The next step that we'll be seeing is let's just visualize a few things. Okay. So let us say I want to see I mean see the plot of how these log returns look like. Okay. So how I can do that? For that, we have a very straightforward function. Okay. So we use log return and dot plot. Okay. And what kind of plot we want is a line graph basically. So I'm just going to execute this. It will take a moment, and you see we have the stocks. These are the stock price, stock log returns fluctuating, right? So you see in this particular year, somewhere around this 2022 and 2023, we have a spike with the Apple. So Apple prices went up drastically, and I hope you can remember it was around COVID, post-COVID time only, right? And recently, if you'll see, which asset class do you expect to see the highest return recently? Can anyone tell from 2025 to 2026? Which asset class performed best across, I mean, across the global markets? Anyone? It's gold, right? So you see gold, this is green one represent gold, and you can see there's a spike in the gold return, right? It's a significant return. You see for and this 2025 6, there's more than 10% return. Okay. All right. So actually these are monthly returns, but if you'll convert this into annual, this will look even, the numbers will look even exaggerated. Okay. So this is how you can visualize it with a simple graph. Now the next thing is we want to see, I mean, these are, I mean, let's say if you want to see a cumulative graph, okay, cumulative means that there's the data points are getting added, right? So we'll take a variable called cumulative log returns, right? And it basically does it adds the data points, okay, one by one. So what is the function here? So we use the function called CumSum. Okay. Right? So it typically does it just keep on adding. So this number, for example, if you look at this number will be added to this, and then this number will be added to this. It works like this. Okay. So if, let me just do this and print. Okay, we want to visualize this graph as well. We want cumulative log returns, right? So you can see this is the accumulation. Okay. You can see gold again here also performing. It's the best performing asset till date. Bond market, because the bond markets, why? Because there have been a lot of rate cuts recently. That's why the bond yields fell in last 2 years. Okay. All right. So this was about the graphs. Now the next thing, okay, few things we can also change in this graph. We can add the title of the graph. We can change the figure size as well. You see, we don't see any label. I mean, what is the name of the graph, and we don't see this. So what we'll do, we'll just again use this function dot plot. We need to put a attribute called title, and we'll call this cumulative returns, right? And and we'll just need to provide the figure size, right? We can also change the kind. So instead of let us say this kind, so let me just put kind equal to bar. Okay, by default, if you're not putting any kind, it will give you a line chart. But if you put, so let us see how it looks like. You see, we have a bar graphs here, right? But if I don't want to put it, let's just try scatter. Okay, so scatter does not work. So they will also show you what should be the right approach. Okay, so you see it is giving us an error. So let me just remove the scatter again. Okay, and let's just put line only. Even if you are not putting line, by default, line graph will be made. You can change the dimensions also. It is 10 by 6. Let's make it even small. So let's make it 5, 3. Okay, you see a smaller version is created. Got it? And for this, we don't need any library in order to print these type of simple graphs. For advanced level of graphs with more detail, we will be using Matplotlib and Plotly to construct those graphs. Right. Okay. So this is done. Now we'll come to the concept of function. Right. So here you see we use multiple functions like percentage change, log returns, right? So you are simply using a keyword, right? But there's a small code which is written inside that particular function also, which helps you to perform that task. But you cannot see that code because it is running behind. So what we'll do, but that function is very standardized function. So what we want is we want to create a function of our own, okay, which has a very specific functionality, right? And that also helps in like let's say if this particular task, I mean let us say if there's this return calculation which we have to do every time, right? But we don't want to write the code again and again, right? We don't want to do this old upon new minus one every time. So how we replace it? We wrote it once and we used the simple name called PCT change, and we are calling it everywhere. Right. So this is called the reusability. So when you use the concept of functions in Python, you actually make the code reusable. So instead of writing the same code again and again, you can simply call that function which will perform that particular task, right? For example, let us say if I want to compute simple interest, okay, and this simple interest will be computed, let's say, at 100 places in the program, but I'm not going to write down every time the formula PRT by 100, right? So what I'll do, I'll just create a function of simple interest, right? Call that function simple interest, right? And whenever I'll use this keyword of simple interest, the Python, my code will understand, okay, within this keyword which I created, within this function which I created, there's a small code written. So instead of writing that code again and again, simply writing down simple interest will work for me. I'll show you how, right? So how do you declare a function? So for that, you use a keyword called def, right? Now let us call this the name of this function should be, right? Let us call this simple interest, right? Now there are few arguments which are needed, right? So the few arguments are what are three things that we need to compute a simple interest, which is principal, rate of interest, and time. So I'll call this principal, rate, and time, right? And this function will not get activated until unless you put a colon sign here. So as soon as you'll put the colon sign, then only you see the cursor will shift to the right. That means now we are inside that function. Now, how do we compute the simple interest? So the simple formula is we compute the interest by taking in these three. So what we need, principal multiplied by rate multiplied by time, and we'll divide this by 100, right? Okay. Now what we want to return is return interest. Now I'll show how this magic actually works. So now I've created a function, right? So let us just and let's just execute this. Okay. So if I'll execute this, so now this function is executed. Now the code has this in within my code, a memory is created for this particular function, and this is now anywhere. If I'll go here, right? If anywhere I'll go, I have since I've already returned the function, what I'll do, I just want to see if there are any particular parameters. So let's just add a cell here. Randomly, I'll just add a cell anywhere, right? So I'll call this, what was the name of the function? The name of the function was simple interest. So I'll call this function simple interest, right? Within simple interest, we need to provide three arguments, which is principal. Let's give the principal as 10,000. Okay, rate as 5%. So I'll just use 0.05 and time, let's make 2 years, right? And just execute this. Right. 1 second. Okay, so see the issue is in the spelling. Okay, so it is PRIN it should be. Okay, so that's why the issue. Okay, so if you again go back to this function wherein, so see that is the definition of the function. So if I'll execute this, okay, now I'm getting the result as 10. So what happens actually? So as soon as you, so this function was already run. Okay, I executed this function by pressing shift and enter. So in the memory, interpreter already read this line. It understood what I'm trying to do. Now anywhere, if I'll mention, so what I'm returning interest, right? So what will happen? So whenever I'm using the name of the function, so as soon as I mention this name simple interest, the interpreter already understood that I am trying to call that particular definition, right? So as soon as I'll mention the simple interest, open the bracket and provide these arguments, what will happen? The interpreter will immediately jump to this portion wherein this in simple interest is getting computed. So it will go understand, okay, I'm trying to call this function, and it will automatically copy the values which I put it inside the parenthesis. So I put 10,000 simple interest, rate as 5%, time as 2 years. So automatically those values will be copied here. Formula will be applied. Interest will be computed and interest will be returned. So return interest. So as soon as return interest will happen, I'll again jump back to my original place wherein I called this function. So this is how it works. Understood? Got it. So even if I change the interest rate, so let's me change the interest rate to 10%. You see, the numbers are automatically changing. So again, in my code, no matter how long the code is, I can just simply call this function of simple interest and it will immediately compute this interest for me. I don't have to write down the code again and again of PRT by 100. Okay. So again, this is a very, very, very simple example, but understand the complexities with respect to the bigger lines of codes wherein you have thousands and thousands of lines written. There, how useful this concept of function becomes, right? So there you'll understand the criticality of using this function. Even in when we'll learn about Monte Carlo simulation, there also you'll see how critical it is to use functions. Without function, things would have been so difficult to understand, so complicated. The code, the instead of 10,000 line, it would have become 15,000 line if we are not using functions. So in order to make things simple, in order to improve the reusability of code, this is what we do. Got it? Okay. So if this is clear, now let us create another function. Now the purpose of that function will be to take the stock prices, okay, and take stock prices, the current day price and the previous day price, and compute the return. So what we are trying to do, we are simply trying to replicate the function, a standardized function of PCT change. So we're trying to create that function by ourselves this time. Okay, so let's just create a function, define a function, the daily return, right? So what we need here, we need the current price and we need the previous price. What we need to return, okay, So what we directly need to return. So see, you don't have to use a variable and compute this. Instead of using a variable, I can directly compute this inside this return as well. So return. So what I want to compute is, how do you compute the percentage return? What is the formula? You take the previous day price, right? You divide it by the current price, right? And you do minus 1. This is how you return the change in the price. I'll execute this. Now, I'll be simply calling this function by mentioning the name of the function called daily return. I need to pass on two arguments, right? What are the two arguments? So I need to provide the current price. Let us say the current price is 110 and the previous price will be, let us say, 120, right? And nothing I have to do, I just execute this. So you see, the return has been computed. So current price is 110, previous price is 120. One second. Yeah, no, it is fine. So I actually wrote down opposite. So it will be current, I mean the new price divided by old price minus 1. So this is how you compute. Now you see, this is exactly what the PCT change is doing, okay, which the function which we used here, this part, right? It's exactly the same thing. So we actually try to replicate what that PCT change function used to do, right? Now let us make it even more complicated. Now let us add few more things. Add looping as well, right? So let us say I'll take a list of stock prices, right? So these are the stock prices for 5 days, 1, 2, 3, 4, 5. Now what I want, that the return should be computed for all these 5 days. Obviously for first date it won't be computed, it will be starting computing from second date, because for first date we don't have any previous day data, right? So I want it to be done one by one, right? So in this case, we'll be combining this function. Okay, this is the function which is so we can create function inside a function also. So we'll create a function that will call this particular function, right? And we'll also combine here the concept of looping, because we want to do things one by one, right? So let's do this and let us understand very slowly, right? So first of all, we need a array wherein I can store these return. I mean, we can store these return, because see, in the previous example, we didn't have multiple values. We just had one single values. But in this case, we will be having four different values, since we have five data points. Okay, and we'll be computing the return. So in this case, we will have four data points, right? Now, daily return. Now, this is an empty array. So within this empty array, the return will be stored. Okay. Now let us just create. Now let us just run a loop. Okay. So you see how we'll be calling this function, right? So what I want is this function, how many times I want to call this function? I need to call this function four times, right? So I want the loop to run four times. So every time a loop will be run, our return will be computed. So first time the loop will be run, a return will be computed by 102 and 100, which should be 2%. Then another a loop will be run. It will be 101 and 102. So there'll be a fall, negative return, right? So this is what I want. So you see what I did? I have declared a loop. Let me just zoom in. I have declared a open a loop for I in range. I want the loop to start from 1. I'm not starting the loop from 0, because I don't want this price. I'm starting the loop from 102, right? And I'm till where I'm running the loop, till the length of this list. What is the length of this list? Let me just create uh, the. I'll show. So how many data points are there? 1, 2, 3, 4, 5. So 5 is the length, right? By default, I've already told you this loop starts from this particular number and it goes till length minus 1. So technically, it will start from this number 1, 2, 3, and 4. So it will start from 1 and go up till 3. Because as I mentioned, as I told earlier also, the index number starts with 0. not with 1. So 100 is at a 0 index number and 107 is at the fourth index number. But the length of the array is 5, which tells how many uh, elements are there, right? So I'm going to do this. Now what I want, how do you compute the return? So in this daily return, right, I want to store the returns. Now, how do you compute the returns? So instead of applying the formula, I'll simply call this function called daily return. See, it is return and this is return, so difference is there, right? I'll call this function daily return. And what arguments I need to pass? I need to provide the current price and the previous price. How do I get the current price? For getting the current price, I'll use this. So see, this is my array, okay, wherein all the prices are stored. How do I get the current price? So let's say the loop starts with 1, so current price will be this only, right? How I can get this? I'll use this I, okay, which is my iterative variable. And how will I get the previous price? So I'll again use this stock prices. In order to get the previous price, what you'll do, I'll make this I minus 1. So technically what is happening when the I value is 1, okay, this is my current price and I minus 1 will be 100 and this will be my previous price. Got it? So these two values will be automatically copied to my this function, right? And I'll simply execute it. Just a second. Right. Also, since this is an array, I want this array to store the prices. So I'll use a function called append function. So I'll just use daily. I want to append whatever is getting computed. I want it to append, right? So I'll use this daily underscore returns dot append, right? I'll break this down for you. So let's just execute it once. Mm, it- So we'll just append it here. Daily return dot append. Let's do one thing. Instead of taking this daily return, let's just compute this first. So for computing, we'll take another variable called stock return. Stock underscore return, right? And in this array, we'll just keep on adding the stock return. So daily returns dot append stock return. Okay, execute this. Now let us see what we get. So what we need to do is we need to just print this. You see, we are getting four data points: 0.02, then negative, then this value, then this value. Right? Why we are getting four data points? I hope this is clear because for this particular number, we don't have any previous day's number. Any doubt with respect to this example? It is the most important example because we'll be building on this logic for Monte Carlo. Again, I'm explaining. So took a list of stock prices. We have a 5-day stock prices. We took an empty array that is used to store the return day on day basis, right? In order to compute the return, we could have used a simple PCT change, but we already created a function which is called daily return. So what we did, we ran a loop starting from 102 till 107, right? Uh, we ran a loop and then we computed the stock return. In order to compute the stock return, we called this function. We created this function on purpose so that this can compute the return, right? So I call this function. I just needed to provide the two arguments, which is the current price and the previous price. So I want this as the current price and this as the previous price, but I want to make everything, uh, I mean, automatic. Okay, no manual labor. So I just passed on I, which is an iterative variable, right? I in the current variable and I minus one in the previous variable. That's it. And daily returns in this array, I just wanted to append all these stock returns. So I just use dot append function, and whatever the stock return I got, I appended it here. Let's say if you want to see all these things in the percentage form, you could have simply just multiplied by 100. Now this makes even, yeah, this makes things even clear. Got it? And you could have added, uh, let us say if you would wanted to add a percentage sign, you could have done this. So for that, we need to convert this into a string, right? And then add plus sign, and then in this bracket, I could have added just percentage sign. Got it? So there's a percentage sign also in there. I hope this is clear. Okay, but I'll just get back to normal. Any doubt? Anyone?
No, sir.
Okay.
Sir, I have a query. What is
Yes,
the
Tim.
use of append function?
It just adds any, so see in this daily, so if you'll go back to the original wherein I taught this append, let me just go back to that example. You see, so this was the list, okay? And if I use values dot append apple, so see what happens, the list changes, there's a new element added, so it basically adds thing at the end of the list. Okay, so similarly here also we computed the stock return, okay, and if I wanted to store that in the daily return array, okay, so I use this append function. So every time a stock return is computed, it just keep getting added to this list. Okay, with the stock prices also, if I wanted to add a new number at the end, I'll use this stock prices dot append function and put what I want to add. Okay.
Okay, sir.
Yeah. Yeah. All right. So next thing which I wanted to discuss is very important from the Monte Carlo perspective. Okay, let's just understand the logic which we'll be applying in Monte Carlo. So, I'll concept of random number generator, right? So, what we'll want, let's see, understand where this logic will be used. So, as I mentioned that later on we'll be learning how we'll be optimizing an portfolio. When you say you are optimizing the portfolio, what you mean is, uh, let's say there are five securities, okay, and if I give you 1 crore to invest, so you need to decide now how much percentage of this money should be invested in which asset. But what should be the logic? What is the fund manager's logic of allocating this capital across different assets, right? So this percentage money allocated to different assets is actually called the weight. It's called the weight of the portfolio. In Monte Carlo simulation, what happens? These weights are randomly generated, right? There's a one condition that the sum of all the weights should be not exceeding 100%, right? So the sum of weights should be equal to one only. But these weights are randomly generated. And for different, since different weights are getting generated, different portfolios are getting created. So let me just show you one thing. Can you see? Right? So let us say uh, Monte Carlo simulation, as the name suggests, simulation. So we are actually simulating the weights for every portfolio. So let us say this is one portfolio wherein we have four securities: Amazon, JP Morgan, J&J, and PNG. Right? This is the first one wherein these are the weights allocated. Now, in this case, 25% is allocated. Now, in the next one, this is a different portfolio, but the securities are same, but the weights are different, right? So in this case, this particular security got 60%, then 20%, other two got 10%, 10%. So what we want to do is we want to randomly generate these weights. Okay, how many times I want to randomly generate? So let us say 10,000 simulations we are doing. That means 10,000 such portfolios will be computed. Okay, so 10,000 such portfolios will be created. With each portfolio have unique set of weights, right? So it would look something like this. So you see, for every portfolio, right, there'll be different set of weights. And for every portfolio, since the weights are different, the return and risk of the portfolio will also change. There's a specific formula which we'll discuss in the next session. right? So what you need to understand, for in order to compute the return of any portfolio, how you do that? You take weight multiplied by the return of that particular security. So it is W1 multiplied by R1 plus W2 multiplied by R2, and so on and so forth. Similarly, we have for the risk, right? So this is how we compute the risk return, and then we'll compute a metric called Sharpe ratio, which is the risk adjusted return. We'll again discuss this in detail. So the whole logic is, what we want to learn from this small exercise is that we will be randomly generating, right? Randomly generating weights for portfolios. So, right. So we'll take, let's say we'll take 100 portfolios, and for every portfolio, we'll be having 5 unique weights generated. Okay. So this is what we want to do. Now I have explained the logic. I mean, what we wanted to create, just we need to replicate the same. So what we want is, it's fairly simple. We want that, let us say we are running 1,000 simulations. So 1,000 simulation mean we need to run a loop from 1 to 1,000, right? Every time a loop is run, 5 new weights should be generated. This is the logic we have created. Now let us just implement it on Python. Okay. So I'm going to take uh, simulation runs equal to 10,000. And now how many weights I want in every portfolio? Let us say I want 5 weights. That means every portfolio will have only 5 securities. So 5 weights I want to generate, right? Now I want to run a loop. Okay. Okay. Before running a loop, let us just create, uh, let us just take an array. Okay. Let us just take an, let us just take an array called wait runs. Now this wait runs is an array, understand, which will have 10,000 portfolios, and each portfolio will have 0 weights assigned initially, right? So how I do that? So the logic is np dot zeros, right? So this is a function that we use to generate zeros, right? Understand how many portfolios will be there? There'll be 10,000 portfolio. What will be the dimension of each portfolio? It will be n, which is 5. So that means 10,000 such portfolios will be created, with each portfolio having 5 securities. And initially, all the weights of these 5 securities will be 0, right? So I'll take this n. Okay. Now let us just execute this and see what we get. One second. Okay. Now let us just print this array. Number of n thousand such arrays will be created. Okay. You see what happened. You are saying just top four and bottom three, top three and bottom three, but there are also multiple portfolios in between. So you see, this is one single portfolio. In this one portfolio, you see 1, 2, 3, 4, 5 such zeros are created, right? What we'll be doing is, we'll be replacing these zeros with some randomly generated number later on. That will be the actual weight. For now it is 0, but we'll be randomly generating these weight, which will replace these zeros. Okay. So how do we do that? That means how many times I want to generate these weights. We want to generate it this many times, right? So we'll take a loop for I in range. So when we are not specifying any range, it means it will start from 1 and continue up till 10,000, right? So every time this loop will be run, random number should be generated, right? How many random number I want to I want to generate in every portfolio are 5, right? So just a right? So let us create one function. The purpose of this function is to create random numbers. So we'll call this weight generator. Okay. Now what this weight generator will do, it will randomly generate weights, right? So in order to randomly generate weights, right, we'll take a variable called weights, and I'll use a function called random.random, right? So what it will do, it will simply generate a random number. Okay. It will simply generate. So NP is for NumPy. Within NumPy, there's a module called random. Within random, there's a function called random, right? N tells how many random numbers should be generated. So I want 5 random numbers to be generated. Now, there is one condition which I want to keep, and which is that the sum of these random number generated for every portfolio should not exceed 100%, right? How do I do that, right? For this, we'll use a logic called weight equal to weights divided by weights or sum. So basically, what we are doing this. So let us say some weight got generated. Okay, we are actually converting that in the form of a percentage, right? And we know that percentage of anything in the world, if you're converting into percentage, it will never exceed 100%, right? So this is called, basically this is we are this we are trying to just converting it into a percentile kind of thing, and we are forcing it that it should not exceed 100%. As more and more weights will be getting generated, the value of these weights will become smaller and smaller. Okay, so let's just execute it. First, let's return what we want to return. We want to return the weights which are generated. Now let's execute it. Right, now let us just call this function. Okay, let me just call this function weight generator. You'll understand what I'm trying to say. So 5. You see 5 such random numbers are generated, and if you'll add all these numbers, it will sum up to 1. Okay, or 100%. Now every time I'll execute this, you see a different set of random numbers are getting generated. You see, every time. Again, I'll execute. You see, every time. And if I'll make this 10 also, you see 10 random numbers are getting generated, but the sum of all these cannot exceed 100 because this is the logic we have used, or 100%. Right? So what we want is every time a loop will be run, a new set of random numbers will be generated. Right? So we want to run a loop. How many times we want to run that loop will be equal to 10,000. Okay. So quickly just create a loop. Right. So for I in range sim runs, weight equal to weight generator. So once this loop will be run, let's say for one time it ran, then this function will be called weight generator, and whatever the weights, these are the weights generated, and these weight will be copied to this weights, right? What is this weights actually? Right? Now all these weights will be actually replacing these zeros, right? So this set which was created, now this one set will replace this one, then again the loop will be run, it will replace this one, and so on and so forth. So you can see we are using this weight underscore runs, which is my empty array. I comma colon, what it means? I means row, right? So this is first row, this is second row, this is third row, right? And these are this basically, if I'll do like this, right? These are column, first column, second column, third column, fourth column, and fifth column, right? So I comma 1 basically means I means all, I mean first row, and colon mean all the columns. Then second row, all the columns. Third row, all the columns. They have to be replaced by these weights. Okay, now let's just execute it. One second. Okay, so for that, we need to just execute one by one. So let's just start from here. Execute this, and then what's the issue? Okay, so 1, 2, 3, 4, 5. Okay, so here I took only 4. I need to add just one more. Okay, now this may take some time. Okay, this may take some time. And now what I'll do, I'll just print what I want to print. I want to print all these weights now. Okay, so instead of 0, there'll be some different weights. So you see, new set of weight have been created for every portfolio, right? So you can increase the number of sim runs as well. Okay, and let us say instead of 5, we want to create 10 securities in each portfolio. So we'll take this. You see, 10 securities are getting added now. Now, if you'll increase one more zero here, na, only if you increase one more zero, or let us take. Now you see this will start taking some time. Okay, you see it is running now. That is why Monte Carlo simulation are very they're very computational heavy. It take a lot of time. These are just for 100,000. So actually, in reality, it is being done for millions and billions of time, which makes it very computational heavy. And sometimes it requires a supercomputer as well. Okay, because the local computer they don't have this much of computational power. And even if you try for let me just add one more zero here. Your see this code is so powerful that your laptop will start getting it will start to get heat. Okay, so if you add just one more zero, so that will make it 1 2 3 4 5 1 million times, right? Not 1 million, it is 10 million. So now see it will take how much time. Now see it is running now this will take significant amount of time because 1 crore such portfolios will be created with random values. Now, this is still possible, but in the real world, I mean, when we'll be running the Monte Carlo simulation with the stock data, then it will take a lot of time because every time, because uh, when we'll be using this Monte Carlo method for a portfolio optimization, for every portfolio, a new risk, new return will be computed, new Sharpe ratio will be computed for 1 crore number of times. So understand how time taking it will become. So you can see we have 1 crore such portfolios ready here. You can't see every portfolio here, but we have 1 crore such portfolios ready. Right? Understood? So today we'll keep it till here. In the next session, we'll start with the portfolio optimization theory. We'll start with the Markowitz concept. Recording and everything will be shared with you. Again, there's no such need to join the call. You recording will be made available along with the code. Uh, right. So I would just say that do watch thing and try to replicate thing so that in case if you guys have any doubt, you can just reach out to me for the same. I hope this is clear.